So, large assembly management is what we're talking about today. We're going to take a look at diagnosing and optimizing performance for large assemblies and best practices, tips and tricks kind of stuff. So, the first thing we're really going to take a look at here is what is a large assembly? What are we looking at, and what are the kinds of things that we talk about when we talk about poor performance? So we'll go overview some symptoms. We'll take a look at good and bad practices. We'll talk about some diagnostic tools that are available, and then some different tools that are new in SOLIDWORKS and some different methodologies that make things easier when dealing with large assemblies. So what are the signs of a large assembly? The first things we see are large times in opening and saving and changing sheets, large rebuild times, and sluggish interactions with the graphics area in SOLIDWORKS, especially when you get pan and zoom and rotations, where you'll tend to get skipping, or you'll do things and it may take a second for SOLIDWORKS to catch up with you, or even the not responding error message, informational message that we see these days. The different things that can cause these sorts of problems. When we say customer or supplier models here, what we're talking about is models from CAD systems that are not in SOLIDWORKS. So we get a high counts of surface bodies, or we get geometry errors. Some bad practices in general here, using a previous year's files. What happens every time we open a file from an earlier version is SOLIDWORKS converts that file to the latest version. So if you don't save those in the new version, we're constantly going to be taking that conversion time into account. Lots of mates or over-defining mates with errors, rebuild errors, too much geometry detail, in context designs, especially if you get yourself backed into a corner with circular references, and then too many files in a single folder. We also have a little bit about hardware here, standardizing on supported hardware and drivers, opening and saving on networks versus hard drives, local hard drives, and uncertified video cards and drivers are all things we need to look out for. For the most of what we're going to talk about today, though, we're going to assume that your hardware is up to snuff and certified and all of that's dialed in correctly. We can talk a little bit more about specifics on hardware later. So really, a lot of the focus here is going to be on your best practices and getting a good start with making the right decisions for your models and your assemblies. So the first thing we're going to take a look at is using supplier data. We want to make sure that when we're bringing in customer data, supplier data, things from outside of SOLIDWORKS, that we're doing the right amount of detail for the job, especially if we're not manufacturing those components and we're not responsible for the manufacture of those components. We don't necessarily need them to be as detailed. We also want to make sure that we are managing the data itself and making sure that the files are good files. And this is where we were talking about a minute ago, all of your files just in one location. When SOLIDWORKS does its searching for its assemblies, it basically starts at the top of the file list and goes all the way to the bottom. So if we have several thousand components in one file location, SOLIDWORKS has to search through all of those from top to bottom, regardless of whether or not that file is relevant to the current assembly we're opening. So we want to make sure that our files are in appropriate buckets, in appropriate folder structures, so that SOLIDWORKS doesn't have to spend as much time searching through large numbers of files. The next thing we need to do is talk about that supplier data. One of the things that kills SOLIDWORKS and gets us a whole lot of very weird performance issues are errors in geometry in imported data. So I've got a file here that we're just going to open up real quick to take a look at. That's a screw that I imported from another CAD system. So this is what we mean with it by imported data. Something with the dumb imported solid body model here. It's very important that whenever you get this data that you do a import diagnostics on it. And you want to make sure you do that before you do anything else to this model, because once you've added features, import diagnostics no longer works. So we're going to run that real quick. And what it finds for us is that we've got a broken face. In here, there's something about the geometry of that face that SOLIDWORKS doesn't like or is not computing properly. So we'll go ahead, and in this case, we're just going to hit Attempt to Heal All, and that's going to fix the face. We can then save the model and carry on. Now, that little tiny defect may not mean anything in the case of one screw, or it may mean a lot for that one screw, but we really need to think about is when we're talking about large assemblies where we might have this one screw used 100 or 1,000 times, any errors introduced into the system by that small face defect are multiplied by the number of instances of the screw. So it's really, really important that we make sure that our data is good and that our models are not throwing any sort of errors in the background. So then the next thing to talk about here is what kind of methodologies are we using? And this gets into mates and how we mate our parts together. And these two methodologies have been sort of the standard practice for a long time. And that is one, mate everything in place, then delete all the mates and fix them. The other one is using mates only. And in reality, there's a bit of a benefit to doing both of those things. When we use just fixing components, we lose all of the control that our mates offer us. But when we use mates, we introduce a lot of processing time into the opening and saving and rebuilding of the models. What we can do, however, is we can build our models, build our assemblies, and mate everything together as we need to. And then we can go ahead and fix everything in place. When we have everything fixed, what it does is it suppresses all of the mates that were already created, allowing us to have that almost like a configuration of the model where everything is fixed. And then if we need to make adjustments to that model, we can go in, suppress the fix, all of the mates will come back, and then all of those mates will update as appropriate to the changes in the models, and then we can fix them again. So that allows us to kind of get the best of both worlds. We can have a model that opens up quickly, but still gives us all the flexibility and control we had with the models. So let me just open up one of my assemblies here. This model, while it's opening up here, has about 5,600 components and about 17,000 mates in the assembly. And it's going to go ahead and go through the, sorry about that, the process to load this guy up. We'll go ahead and rebuild him. And right now he's in our speed pack configuration. So let me get us into our regular configuration here. And we'll talk about speed pack here in a minute. But the benefit of speed pack also, one of the benefits speed pack also gives us is it does load models incredibly quickly as well. That one loading in about 30 seconds. Now that I switch over to the default configuration, it's going to take a minute or so as it resolves the components. And so like I said, we've got 17,000 mates, about 5,600 parts in this model, and it was built using that hybrid methodology. So we have all of the models are connected with mates, and then once everything was mated together, everything was fixed in place so that it didn't move and was in the appropriate location. So we've got a number of subassemblies and things in here, and we can see that, well, that one's got the mates already. I may have left a bunch of these already unsuppressed. Here we go. So just to demonstrate, when we have this fixed in place, you can see the fix because we've got the F there, and it shows that all of the mates are now not being resolved. If I come up here and I choose to float that in this configuration, for example, what it's going to do is it's going to recalculate all of these mates at that time. Now all of the mates are live, and whatever motion this part might have is accessible to us. Or if we had made an update to this part, it would now then update those mates appropriately. And then when we're done, we can again go back and say fix. And it just takes a few moments to process, and then all of those mates are suppressed again. So again, we have the ability to have that control and flexibility and still get some of the benefits of the speed and performance we get when we fix things in place. So next, we'll go back to take a look at that speed pack, like I said. And what SpeedPack does is when we generate a SpeedPack configuration, it only saves the data for specific faces and bodies. So in this case, if we look at the bottom of the landing gear, all of the faces at the bottom of the landing gear are still there. So if we were to take this large assembly and add it into yet an even larger assembly, we could still mate with those faces or with any of the other surfaces that we are leaving intact in the speed pack. And it still allows us to access those things for mates and other functions, but everything else is turned into graphics data so that it doesn't bog down the computer. So that also gives us a lot of flexibility and control in how we're using things. Okay, we'll skip back to there. So when we're using the fixed methodology or the hybrid methodology or SpeedPack, what we can do is get drawings to open faster. And another thing we see is with shaded views. When we're already doing all of the rendering and shaded views, we can often get shaded views to work in drawings just as quickly. So when we opened up that model, one of the things you'll notice is that it popped up this window here that told us how many components were being opened, that it was updating the assembly, and it gave us some information about how long it took previously and how long it's taking right now. Anytime you open up an assembly that takes longer than 30 seconds, I believe, that window should pop up and give us that sort of information. The other tools we have now are performance evaluation and assembly visualization. These tools will let us dive into the model and search out problem components or problem geometry that we can then make adjustments to get better performance out of the models. So if I look at our lovely spaceship here, the Millennium Falcon, and we go to the Evaluate tab, we can take a look at the performance evaluation right here. And this gives us a lot of different information on what's going on in the model. Right here, up front, all files are the current version of SOLIDWORKS, so that's nice. It gives us some open times, so we can see which components are taking a long time to open. Graphics triangles and display performance. So the graphics triangles, so this shows us a particular configuration of a component that uses a lot of graphics triangles. and that there's 243 of these components in that assembly. So if we can do something with this particular part that might make it less detailed, or maybe just reduce the number of graphics triangles, we can maybe bring down that load and rebuild time as we carry on. We also get information about 5 documents contain over 100 appearances, so a lot of different appearances can affect the performance. We've got 130 parts with medium or high image quality in the document properties, and each of these things comes with a model, a link here, so that we can link to that and open those files and take a look at it. You'll also notice that in this case, it says that we can improve display speed for this model if we're in large assembly settings. Right now, I'm not even using large assembly mode. These 5,000 components loaded in about a minute, and they're all fully resolved. Here's also some other different settings that can help with performance in general. And down at the bottom, we have sort of a total number of components and how they're used. So I'm going to come up here and we're going to go ahead and open up. I'm going to open up this part that is taking the longest time to open. That should have opened it up in the background here. So this is the part that's taking a really long time to open for some reason. And it was in one of the other configurations. But we can take a look at this individual component once we see that it's got some issues. And we maybe take a look at the performance evaluation on that component. And we can kind of see, okay, we've got some patterns here that are taking up a lot of time. Specifically, this L4 pattern is taking up 63% of the time of rebuilding this model. And in this case, we're only talking about 1 second. But again, if this model takes 1 second to rebuild and we've got 100 of them, that's 100 seconds. If we got 1,000 of them, that's 1,000 seconds. So anything we can do to reduce these times when we find that we've got parts that are causing trouble can be helpful. So we can take a look at this pattern and maybe find something in that pattern that we could do differently, or maybe use geometry pattern or something like that. All right, and then the other tool we have is assembly visualization. What assembly visualization does is takes a lot of that same kind of data and applies some visual filters to it. So in this case, we've got SOLIDWORKS open time and SOLIDWORKS rebuild time as our 2 columns here. And we can change these columns, or I can add additional columns to add other things. So that one added this column. Yeah, here we go. Total weight. So there's lots of other things too here that can be super helpful beyond just performance issues. We can take a look at things like weight, mass, density, and other things to sort of get an idea of the different states of our assemblies. And if we come in here, we have a whole list of other properties. So we've got rebuild time, open time. The other thing that we find often has a bit of a effect here is we can look at those graphics triangles again as well. All those sorts of things that we saw in the performance evaluation, we can also apply to assembly visualization and get a look at these models. So let's actually look at our rebuild time. And so we've got one thing here where it's 2 parts. It takes almost a second to rebuild those parts. So maybe that's not such a big deal, but then we see here there's 18 of those and they have a relatively high rebuild time, 17 of these, 36 of these. So when we see that sort of stuff, we can kind of take a look at those individual items and see if there's pain points inside the assembly that maybe if we went in and again did something with a lower level of detail, or if we uh, could do something with that model to maybe make it rebuild better, we can get better performance. So that tool is another way to kind of get at that data and see that data sort of visually applied to the model. Okay. So here on the performance evaluation tab, again, it just kind of shows you the different stuff that we were just walking through. And again, assembly visualization. These are all things that we can take a look at to diagnose the different states of the model and find different ways to sort of improve our assemblies and the components inside them. And again, the other thing with bad supplier data is, don't be afraid to go back to your suppliers and your um, customers if they're sending you data. Maybe try other file formats. Or if they're working with SOLIDWORKS as well, again, maybe you don't need the fully detailed model. Maybe they could just send you a speed pack. That can protect both their data, by not giving you everything, but also only give you enough to be able to do the job that you need. Okay, so then next up we have some different options for what are the out-of-the-box uh, tools that are inside SOLIDWORKS right now to get us the better performance. So whenever we open up an assembly, we have some choices to make. We can open it up in resolved. This is the default state of stuff in SOLIDWORKS, and it fully resolves and takes a look at all of the different parts of the geometry. Then there's lightweight mode. Lightweight mode only opens up the previously open data, essentially, a subset of the model data, not the full and fully featured models. Then we have large assembly mode. Large assembly mode, not only does it open up all of the components in lightweight, but there are a number of other system settings and display settings that it turns off, like real view and verification on rebuild and things like that. And those then allow models to open up faster. And then we have large design review. This is the fastest and least resource intense mode. However, it really doesn't allow you to make any changes to the assembly or components. This really is for just looking for the most part. Oop, I got ahead of myself there. Yeah, so this was all of those things. And as we open components, this is where you can see those different modes and the different configurations, and how you can open up the different configurations of any particular model as you open it. Yep, and then so with lightweight mode, it loads everything in lightweight, and then if you need to make any changes or edits, you can resolve any specific component or all of those components as you need to. Large assembly mode. Large assembly mode in the settings has some options for the threshold. Both large assembly mode and large design review mode have these options where you can turn it on so that it defaults to those modes once a certain part count threshold has been met. Another option we have with large assemblies is converting them into bodies, so essentially saving them into a part. This can maintain a lot of the complexity, but again, it takes out all of the motion and it takes out a lot of the um, flexibility and control on a model. So if you spend a lot of time building a model and making sure everything moves and does everything correctly, this would be the kind of thing you do as your last step. Save it into a part that can be used for the drawings and references that are appropriate, while losing a lot of the flexibility and intensity of the model, um, that you no longer need once you've got it fully designed. And so here's just a quick screen that kind of shows, again, some of those different things that get turned off when the different modes are being used, and different things that, again, at certain levels, you may want to play with some of these settings to get performance to be a certain way, or if you're having particular performance issues, you might try taking a look at some of these settings to see if it doesn't help get your performance to where it needs to be. Okay, and then with large design review mode, these are primarily for viewing. We have some limited functionality, so cross sections, walkthroughs, measuring a little bit, that sort of stuff. And it does allow us to selectively open and load some components. But again, it's primarily meant for viewing of very large assemblies and things. For drawings, one of the neat features we have is the ability to load all of the sheets, or we can load just some of the sheets. So if we're working on a large drawing set, but we don't need to actually edit all of the sheets, we might load just specific sheets where everything else will load in quick view and can be resolved if we need to edit it, but we can just load the sheets we need, which becomes super helpful. So we don't have to constantly be loading the entirety of the model. And that will also allow us to do, edits and save in reasonable amounts of time. And then new for 2020, we've got the SOLIDWORKS detailing mode, which allows us to add annotations, balloons, and add or edit some dimensions along with saving and printing. And it's almost like detached drawings, but it's a lot quicker. And I can show you that one real quick too. So in here, I'm just going to my recent models, and if I click this button, I now have those same options we do when we see the File Open menu, and I can go ahead in here and say Detailing, and then Open. So these are the things it shows us that we can that allows us to do in the detailing mode, and I'll click OK. And so now we've loaded this up. It hasn't actually loaded the model. We're using, again, sort of last saved tessellated data. And I can come in here and I can add balloons that maybe got forgotten, things that got missed, especially if it's things like notes and typos and whatnot. Nobody wants to sit and wait for a model to load if it takes a really long time just to change the spelling on something, right? But I can also come in here and add any dimensions I might need to. Not that these particular ones mean anything, but just to show you that you can go in here and add dimensions to any existing edges in the model. So detailing mode, super handy, a super powerful new tool that really does kind of allow us to do a lot to our drawings while saving some performance time. So some other considerations to take a look at, using subassemblies. When we use subassemblies, we can contain a lot of mates and things, and then when they're at the upper level assemblies, they're treated as components. So we don't have to re-resolve all of those individual mates. Control Q. So Control Q is something I talk about a lot in tech support to folks. And a Control Q rebuilds everything in the tree from top to bottom. So if you're doing smaller edits and not needing to rebuild everything all the time, that stoplight up at the top is a really good tool to use that's not going to rebuild everything. But when you're getting to the point where you need to make sure that your entire model is good and your entire assembly is functioning correctly, you go ahead and use that Control Q to really kind of sort everything out and make sure everything's working. Top down, especially in the case of very large assemblies, top down really does slow stuff down, and it makes it hard to work as a team on some of those bigger projects because you have to be very, very careful about all of those references and making sure that you don't end up with references on top of references and that sort of stuff. And when you rebuild, especially with top down, because of the way those sorts of designs are linked across multiple components with those references, that's where you really end up running into a lot of slowdown. And then our graphics, modern video cards are really, really slick, and we are getting more and more advanced video cards these days. The new RTX cards from NVIDIA are pretty amazing at what they can do. And in 2020, with the enhanced graphics modes, with the proper drivers and whatnot, we really can offload a lot of processing onto the graphics card versus the processor. So we can get a lot of big performance gains out of that. But what it does require us to do is make sure that we're staying on top of using certified cards, and that we're on top of our drivers and making sure our drivers are up to date. Okay. Yeah, and then so hardware. The things to talk about hardware. And so, like I said, for most of the presentation, we just sort of assumed your hardware was up to snuff. At this point, we could we'll go over a couple of specifics here. SolidWorks now suggests 16 gigabytes as your minimum. And this has just as much to do with SolidWorks as it does with just Windows and all of the other programs you might be running. SolidWorks doesn't always eat up that much RAM in and of itself, but when you're running SolidWorks and Excel and Outlook and all those other things, RAM resources can get used, and it's one of the relatively cheapest ways to improve your computer performance is just to have more RAM. The GPU, again, that's the video cards. SolidWorks does publish a list, although they've gotten more narrow as time goes on. And right now on their graphics processor webpage, they've basically removed anything older than 3 years as certified. So right now, all of the certification information really just kind of covers 3 years of time. CPUs are one of the biggest bottlenecks and where you get the most for your money, honestly. You really do want high clock speeds on your processors. With the way a lot of technology is working, and you can get a lot of on-demand overclocking these days, the initial number is not as important as the number that it can get to under those turbo speeds and things like that. SolidWorks suggests 3.3 gigahertz, and I agree. The bigger that number, the better. These days, those you really have to take care, and a lot of the new processors that are coming out are, especially the i9 Intel processors. What you see is that there are 12 or 16 logic processors there, but they're all only at maybe 1.8 gigahertz or 2 or something of that nature, something really pretty low. Because SolidWorks is still primarily a single thread operation, a single core operation, we want to make sure that any of those cores is running at the higher level numbers. So not the sort of effective speed. We want the actual clock speed of those processors. Networking versus local drives. Again, whenever possible, you want to save to your local drive. And for things like backing up and just security, send that stuff up to a network from your local drive. But it pays to work from your local drive and just sort of remove out any sort of network latency whenever possible. And if you guys are using PDM, PDM does that for you. So that's one of the major advantages of PDM. External drives, if you're using thumb drives or external hard drives, really USB 3.0 is the way to go. Anything older than USB 3.0 is going to be pretty slow. USB doesn't seem to be terribly prone to issues with packet loss, but it is just generally slower. And again, standardized hardware and configurations So if everybody's on the same computer, same hardware for their computers, then it's easy to take results that work well on one machine and apply them to another machine. If you've got a wide range of computers at various different levels of power, it can be difficult to optimize your performance because you have to sort of apply that to a wider base instead of um, much more narrowly defined. Okay, so thanks for attending.